Turn around and wave. Camera's on. That's just a little bit so I can watch myself teach. What? Because then you'd be distracted by holding it. That actually works pretty well. Hey, grab a piece of paper. Whoever didn't grab a piece of paper. No violence? Yeah, we'll get to that. I know some of you still have to wrap up your clipboards. I have about a 20-minute lesson today, and then we'll kind of break up and get some stuff done, okay? Okay, so today officially marks the start of our personal projects. Okay, so now that means we are going to have to start planning our own projects, right? Our own personal projects. How many of you kind of started on a sketch while we were wrapping up clipboards? I knew there were a few of you in here that kind of started, but didn't quite get all the way there, right? So, what I want to talk about today is some design stuff. So some drawings and how we are going to put our project onto paper so then we can estimate the materials we're going to need to finish the project, or excuse me, to build the project, right? So, who knows what we do before we start a project? There's something that we start to do. We do what? A few of us started in here, right? What was that, Jamie? What did you start doing with your project?
I started measuring how big I wanted it and sketching.
Right, measurements and sketches, right? So that's essentially where we want to start with our project, okay? So I want to build this shelf. Okay? I want to build this shelf. Okay? This is, for right now, this is just an imagination. Okay? I don't have it in my hand. But I want to draw it. Okay? So, who has a good idea where I might start with my drawing? I've got this picture of this shelf in my head, and I want to draw it. Ella, where would I start? Okay, so we're going to start with what I want my top to look like. Is that just top written on here? Is that why you said that? Okay, so if I'm looking down at this shelf, we'll start there. So if I look at this from the top, what does it look like?
A big board.
Yeah, it's an easy question. You can't overthink it. It's just a rectangle, right? So all I would see in that drawing, right, all I would see from the top is this. Right? So is that it? Is that all I need? So then I say I want this to be 13 inches by 3 inches. Am I done? That's my shelf, right? That's what I'm going to set stuff on. What do I have to do next, Jamie? Okay, so I have to draw what it looks like from the side, right? So it's probably going to look, right? I saw my top, it's a rectangle, right? Then my back, and then the side. That's ugly. I think I'm not grading myself, right? Okay? Now I need another drawing, or another sketch else do I need to see? Allie?
The bottom.
The bottom? Do I have to see the bottom?
Yeah.
How about that part? What's that one?
In the front of it?
The front.
Yeah, the front. Very good. So this is going to look, right? I have my top again. Okay? And then these are just going to look like rectangles. Even though we know they're angled, right? They're still just going to look like rectangles from the front. Right? Because we can't see what we see from the side if we're just looking at the front, right? Okay? So, now, do I have everything I need to start dimensioning my shelf?
Yeah, probably. No, you need the measurements.
So do I have everything I need before I start dimensioning?
Yeah.
Yeah? So I think that's a pretty good representation of this shelf, right? Okay? So does anyone know what this is, what I just did, or excuse me, what I drew on the board? Does anyone know what that's called?
Sketchy.
It's sketching, but there's kind of a specific name for this type of design. Does anyone know what that is?
Sketching in woodshop.
Sketching in woodshop. There you go. You got it. Nope. So it's a type of blueprint, or we use it when we're making blueprints. Okay. So that would be like our layout, or it's called an orthographic drawing. It's 3-view. Okay. I didn't think you would. You were? I knew you had it in your head. You just didn't say because you were tough, right?
Yeah, he's not allowed to talk.
Okay? So that's our 3 projection views, right? Because we're projecting the top, projecting the front, and the side. So we just did a 3-view drawing. Okay? And that's what we're all going to do as a class before we start our projects. Now, one thing to remember about a 3-view drawing is that when we draw our top view, like Ella said where we're going to start, this isn't going to be in our drawing, but this is for you to visualize. Our lines match up. Okay? So I can now see that this is my top and this is my front. And this is the same piece, but I'm seeing the top surface and the front surface, right? The top plane and the front plane. Okay? So we have our top, our front, and our right side, right? Now, when I look over here, our heights are going to match up. Or I just drew them unstraight, but I make them match up. Okay? So those match up, and the bottom matches up. Okay? In theory, they should be perfectly straight, like horizontal with each other. So this should be perfectly vertical, these should be perfectly horizontal, all the lines we have on here. Okay? What questions do you have for me so far about 3D drawings? None? Everybody's got it?
Yeah.
So I've got another example for you, okay? So if I look at this cube, right, and this is sometimes a tough one because we can't visualize the different views, right? Because it's just perfect. I did take a lot of time to build this, by the way. It took me a while to get all the sides correct and tape on it. So you guys should
Is it gonna
have an appreciation for my hard work, okay?
What if it breaks?
It won't.
On
It's
November
stuffable.
4th.
Huh?
So I said my phone and then
Phone is in my box then. Okay, so back to what I was talking about. This is a little bit difficult. We visualize it as a 3-view, but they're all the same, okay? But our top, our right side, and our front project out like so. So when we have like similar to our shelf, right? Our top is above our front, and our right side is to the right of our front. Okay? We always look at what we're going to look at on our project when we walk through the doorway and see our shelf. or when we walk into our bedroom and see our end table, what am I going to see first? Okay, that's going to be the front. And I know sometimes like an end table like this guy, if you had this in your bedroom or in your living room for a coffee table, you'd be looking down at it, right? That's where you would gain a perspective, and that's an element of design, a perspective view, but we aren't going to quite go into that. We're just going to look at it in 2D planes, right? So just the front, you only see the 2D lines. So just the front of this, I only see the lines, right? Then I come to the side, I see the lines at the top and the lines of the leg. That's it. Okay? So that's one thing about this that helps some students visualize is we have a top, a front, and a right side of every object. Okay? So if I turn it like this, yeah, it looks like a cube there, but the right side looks like a cube, and so does the top. Okay? Now, does anyone know what the word is for, like if I 3D draw an object? It starts with an I. It's a tough word.
3-dimensional.
Does 3-dimensional start with an I?
Yeah.
No.
Dimensional.
I-mentional.
Yeah.
You're getting warmer.
Actually?
No. Not at all. Okay? So it's called isometric drawing. Okay? And I'll draw this box right here as an example. Okay? And this is a way we can represent our object in 3D. Okay? See if I can draw this bad enough for you all to understand it. Okay? So with isometric, we have all of our horizontal lines are represented on 30-degree angles. Okay? So we start with our leading point here. Okay? Our vertical lines are still vertical, but then our horizontal lines are at angles to give us that 3D effect. Okay? So that's starting to look like a box? A little bit?
Yeah.
It's okay if you say no. Okay? So we notice these are still vertical, but then the horizontal lines are turned and projected at a 30-degree angle. Okay? So like our long edge here. Essentially, isometric is a fancy way of saying I'm making my object in 3D on 30-degree angles. That's all it is. Okay? Okay? How'd I do? Now does it look like a box?
It looks great.
Okay? But the cool thing about this is if we put it on our drawing, what's our front going to look like? So I give you this, and I want you to draw it in a 3-view drawing. How's this going to look from the front?
Not good.
Not good. Mr. Frisbee's drawing it, so it's not going to look good, right? Okay? All we see in this is a rectangle, right? So our front is going to be something like that. Right? How about our right side?
Rectangle.
Just a rectangle, right? And we remember our lines match up. That's it, right? So our front, right side. What about on top? Just another rectangle, right? But it's got some little bit more width. Wait, that's our front, right? So our top's going to look like that, right? So if I have it here, my top isn't all of a sudden going to be turned, right? Nope, we have to keep our orientation the same. Okay? Because when we move from right to front to top view, what do our lines do? The lines in this match up, right? They match up with these lines. Okay? So now, I've learned ways that I can draw my object. Okay? So I did my rough sketch. So I started out with my sketch of my shelf, right? And I want it to look something like this, okay? Because I got a crooked house, and I want it to be on an angle. Okay? I started out, I want it to look something like that. Okay? That's it. Then I decide that I need to draw it in a representation that I can put dimensions on, right? That was just a freehand sketch. So shelf, these here, here, I know it's going to have a little back, and then up here. I want my shelf to look kind of like that. Okay? But now I've moved it into a 3-view drawing. Okay? Now what's next?
Adding dimensions.
Very good. Adding dimensions. Okay? So now I start and say our dimensions can be for design or because of constraints, right? Does anyone know what the word constraint means? Limited. Very good. You guys nailed it. Okay? So for example, our bookshelf back there with the cabinet, right? If I needed to build that shelf on the top, okay? So that shelf all the way back there by Cyrus. Okay? I need to build that one on top, and in our case, it fit back there perfectly, right? But I am given this cabinet and I need to build the bookshelf. What's a constraint of this shelf? Could I build it so it was all the way out here and stack books and fall down? So what would a constraint of this shelf be?
No width.
The width. Very good, because it has to sit on here. Okay? And if I had another cabinet here, it would be restricted in 2 directions, right? I have a wall and a cabinet, it can only fit right there. Okay? So our dimensions can function as constraints or for design, right? For aesthetic. Okay? So some things have certain dimensions because they look better to the eye. Alright, so our shelf, I said, is going to be 13 by 3. Okay? And now, to properly write dimensions, we have extension lines to our dimension with arrowheads at the beginning of each arrow, okay? And our dimension in the middle. Okay? That's how we dimension something. I don't just write an arrow and say, okay? Because this doesn't tell me what line in here is 13 inches. Right? Here, I can look at it, I see the extension lines come up, and I know that the length is 13 inches. That make sense? So we want to make it so we can read exactly where our dimensions start and where they finish. Where they begin and where they end. Okay? So what questions do you have for me about dimensioning? None? Okay. So now, somebody throw out a number for this back piece, the length of the back piece.
8 inches.
8?
5. 2 inches. 7. 3 inches.
It's approximately 8.3 points.
It's gonna be similar to this, right?
3.
Okay, so we'll go with 3 back here. So I'm going to draw my line to here, 3 inches. Okay, now, do I need more dimensions? I've got the size of my top and the size of my back. What am I missing? This? 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 measure right here, right? And who's got a number for me? It's got to be less than 13, right?
12 and a half inches.
8.
Does that look like 1 inch or half an inch?
7.
You got a good guess? I would say it's
5.
probably going to be around 8 or 9 inches, right? So we'll go 8 and a half. So everybody's happy, right?
Sure.
Now, there's another dimension that I need before I can build this shelf. So I've got the width of my bottom. I've got the size of my top. I've got the size of the back. How about the thickness of our wood? Half an inch. That sounds good to me. Okay? So this one here is going to be half an inch. One more. That's kind of an interesting dimension that we need to figure. Ella? It'd be a word that starts with an A.
Asymmetrical.
The asymmetrical? Who said angle? Angle. Very good. So we need this angle, right? Now, if this is 3 inches, and this is 3 inches, okay? So if this is 3 back here, and this is 3, what do I know about these two angles? Who knows? We got a 45, 45, 90, right? 90 degree here, and two sides are the same. Okay? Remember that? A triangle with two of the same sides has 45, 45, 90, right?
Sure.
No, it doesn't always. Does it? Maybe I said that wrong. I think I did. I don't think it has, but if it is a 45, 45, 90, then the two sides are the same, right? So if this angle would then be 45 degrees, right? Or we're going to make it 45 degrees. Because we have two equal sides, so that makes it easy for us. 90, and then our sides are equal, so we can make the two angles equal. Always, sometimes, and never, right? You guys do that in math class? At least I had that when you were in math class. You had to like answer questions and they'd say always, sometimes, or never.
Oh yeah, we did that last year.
What do we do?
It asks you like a theorem question, like an angle, side, or something like that, or a trig question, and then you have to circle always, sometimes, or never.
Oh, yeah, we
Yeah,
Like
we
true
did
and
that.
false, but it'd say always, sometimes, or never. Yeah,
Thank you,
those are the days, right? Okay, so now I have my project dimension. I've got it sketched. I know what I want it to look like, and I've got a dimension. Now what do I need to do? This? I don't have to because I already drew it here. So you can do one or both. That's just a way you can represent it in 3D. You gotta make it. But what do I gotta do before I make it? What?
Do your list of materials.
Good. I gotta figure out how much material I'm gonna need for this, right?
Yeah.
So I have, right, I'm going to have one piece at what? So length is, and then my width is what? And then what did we say my thickness was? Do you remember?
Half an inch.
Okay? So I need one of those. Okay? And then I need, what was the dimension on this one? Remember this back piece? By what? By, and I need one of those. And then I need two more parts. That. However, if this is 3 inches up here, and this is 3 inches, I could cut those two pieces out of what? Two triangles will make?
A square.
Good. So what size would my square have to be? But we would shape that by sanding, right? We could make it straight, and that's what we're gonna do in this case. Okay? So in reality, my drawing over here should look like this. Okay? Straight as I can get it. Okay? So, how big would my square be? Good, so I could use one 3" by 3" by 1.5 piece, right? And then cut that again in half. Okay? So now I have all the dimensions of my parts, and I made my cut list, right? So these are all the pieces I need to cut right here. That's it. Build this shelf. We agree? Yeah? I agree as well. Okay? So now I've got what I need to cut. Do I just go grab 3 boards out of there because I need 3 pieces? Yeah, do I just grab 3 boards out of here?
No.
Why not?
You can cut the wood.
But I have 3 pieces.
But you can cut these into that using just one.
So I can. Wait, you're telling me I can make 1 shelf out of this big board,
Yeah.
and that's it?
No. You make
What?
You make like 6
five
shelves.
shelves.
So how would we estimate how many shelves I can make out of this board? So everyone in here wants to build a shelf like we wanted to build, like we were doing before. So our first project is all shelves. How do I calculate how many shelves I can get out of one piece of board? Okay, so this board is 100 inches long. It's 1 inch thick by 10 inches.
Yeah, you could probably make like approximately 6.
I think you can make a lot more than 6.
9.
You gotta clean it to 15. Yeah, you gotta clean it.
Yep, so it's down to 1/2 inch. But it's still the same board, right? So we lost our thickness. Because we can't rip this down and use 2 1/2 inch pieces, right? We wouldn't have 1/2 inch pieces. Okay? So who knows where I would start? Wyatt told us it was just 6, we could make 6 shelves out of this thing.
I'd say approximately 12 now.
So I feel like I could just make like 17. That'd be good enough for one of my 6th grade classes. That, that's good enough.
No.
And then, so I've estimated my board, and I only ended up making 12. And this was my only board, but I estimated 17.
You just gotta measure it.
Okay? So I measured it. It's 10
You
inches.
gotta measure all the things in total. All the shelves that you got.
Okay, so who wants to help Wyatt there? He said we've got to measure all of our things in total. Okay? Ellis, stay with me. Okay? So, could we use maybe our cut list to help us? Okay, where would we start?
You multiply it.
Okay, so I need somebody to raise a hand and give me something logical here. I don't want just random orders of operation. Okay? So, who remembers what I just said our board was? What the dimensions were on our board?
1 by 10.
Okay, it's what? 100 inches by 10 inches by 1 inch thick, right?
But we planed it down.
We'll get to that in a second. Okay? Yes?
So, could you add 13 plus 8.5 and then divide 500?
How'd you do that? Add 13 plus 8.5 plus 3, so we have 24.5.
You can make 24 and a half boards off
No, because that one you would have to like
Right, because we'd have a maximum length we could get. So that's one way we could just start adding all our pieces together. But what is one way that I could take these and use this? These actually, we're not going to really worry about the thickness, right? Because we know for a fact all of our pieces can come out of that board. Right? Thickness-wise. We aren't worried about thickness because we only need a 1/2 inch, and that's 1 inch. So So we know we're gonna get our half-inch pieces out of it. But I know I can get as many half-inch pieces out of that board as that board has, but we don't know how many of these pieces, and these pieces we can get, right? But we know the thickness will come out of them. Does that make sense? Or no? You're all just blank staring at me. Brett, does that make sense?
Yes.
Right? Because we got to, how thick's our board again? Our board, not our pieces. Nope.
Nope.
Landon, you want to help him?
One.
Right. Okay. So stay with me over there, guys. Our board is 1 inch thick, and our pieces are only ½ inch, so we aren't worried about that constraint, right? Now, I'm left with two values, here and here. Okay, right? These two. Okay, so I can calculate the surface area of that board, right?
Yeah.
Which would be what? 100 times 10. So I have 1,000 inches squared of board. Okay, that's all the surface area I get. Now, how am I going to find out what I can pull off my pocket? Okay, so 13 times 3, 8.5 times 3, and 3 times 3. Okay? So these all came from my cutlets. Okay? So 13 times 3 is 39. 39 plus
25
25.5
plus 9.
plus 9, which is what? What? It's 24 plus 3 halves. It's 25.5. Make sense?
Then you add all of them.
70 something. 70
Yeah,
something.
we're 74.5. 73.5. Okay? So each shelf is going to take up 73.5 inches. Right? Now what do I do?
Now you measure 17
Nope. Because we're doing inches squared, so we're doing surface area of all our pieces, right? Raven, what do you got?
You divide 1,000 by 17.5.
I thought you were going to tell me what that was.
Oh.
I'm just joking. Yeah, that's what we do, right?
I think it's approximately like,
We know it's going to be over 10, right?
yeah.
73.5, right? 13.6.
Yeah, I said there was gonna
Now.
be 12.
Can I round up? Can I make round it up? I have to round it down, right? Because I would have a bunch of small pieces or I'd have to add wood up. So I can make 13 shelves. And that's if we don't mess up, right?
I said 12 pills.
But what I want you to take from this is you can now